Morning. Okay. Good morning and welcome back again. I'm Miss Hinda Ali and this is Science Equals Fun. In the previous session or video, we've talked about the first two atmospheric layer, which are troposphere and stratosphere. I think it's time to talk a little about mesosphere. Shall we start? Let's go. The mesosphere is the third layer, or we can say it is the third middle coldest layer. Why we call it a coldest layer? Because as we go up, we notice that the temperature keep decreasing. So it is the top of the mesosphere. We notice that the temperature has become minus 90 degree, and this is very cold. So we call it the coldest layer. Why? Because as we go up, we notice the temperature keep decreasing till we reach the top of the mesosphere, which is mesopause. We notice that the temperature has become minus 90 degree. Okay, and the mesosphere extends from 50 kilometer to 85 kilometer. From 50 to 85. It's not 90. It's for the 90 with a little. It's 85 kilometer. Okay, this means that the thickness of the mesosphere equals 35 kilometer. Okay, so the thickness of stratosphere was 37, while the thickness of the mesosphere equals 35 kilometer. Okay, and if the temperature, okay, the layer is much vacuumed or highly rarefied. Okay, rarefied. Why rarefied? Why vacuumed? Why? Give reason. Because it contains only a limited amount of hydrogen and helium gases. So when he asks you, give reason. The mesosphere is much vacuum. Why? Or rarefied. Why? Because it contains only a little amount of helium and hydrogen gases. Okay, you may think about this. In which layer do we live? We live in troposphere, stratosphere, mesosphere, or thermosphere. Of course, we are living within the troposphere, of course. Okay. In the mesosphere, we notice that the meteors burn in this layer. Why? Due to the friction with air molecules. Okay. We have celestial rocky masses. Imagine this with me. We have celestial rocky masses in the space. These celestial rocky masses is trying to get into the Earth. What happened? There is a friction like you can see in this one here. The friction here, the friction here between the air and these celestial rocky masses make it burn, forming a luminous meteor. Okay, what is meant by luminous? When you hear the word luminous, it means that this object can emit or emits. This object emits light. Like what? The sun is a luminous object. The electric lamp, the torch, the what else? Flashlight. All of these things emit light. So this means that all of these objects are luminous. So when you hear luminous meteors, that these meteors kind of emit light, or you can observe light when you see them. So I will repeat this again. Here in the space, we have celestial rocky masses. These celestial rocky masses trying to get into the Earth. What happened? It will have this force of friction between it and the air. So we have a friction force between the air and these celestial rocky masses. And as a result of the friction between air and these air molecules and these celestial rocky masses, it will burn, forming a luminous meteors. Okay. Let's move to the next one, which is the atmospheric pressure. We notice that we've said that the atmospheric pressure as a troposphere keep decreasing till we reach the top of the troposphere, which is tropopause. We notice that the atmospheric pressure equal 1 millibar, and as we go up in the stratosphere, we notice that the atmospheric pressure keep decreasing till we reach the top of the stratosphere, which is tropopause. We notice that the temperature become 1 millibar, And as we go up in the mesosphere, we notice that the atmospheric pressure keep decreasing till we reach the top of the mesosphere, which is mesopause. We notice that the atmospheric pressure become 0.01. So again, troposphere, we notice that temperature keep decreasing till we reach the top of troposphere, which is tropopause. We notice that the atmospheric pressure become 100 millibar, and in the stratosphere, it keep decreasing till we reach the top of stratosphere. We notice that it become 1 millibar, and in mesosphere, it keep decreasing as well. And we're talking about the atmospheric pressure in case you have forgotten or something. Okay, the atmospheric pressure keep decreasing in the mesosphere till we reach the top of the mesosphere. We notice that the atmospheric pressure become 0.01 millibar. 0.01 millibar. Okay. And if you have noticed that 100 divide 100 equal 1, and 1 divide 100 equal 0.01. I think this will make it easy. So we'll start by 100 and keep dividing on 100. Okay. Let's go to the fourth one, the fourth layer, which is the thermosphere. So as we've said, we have 4 layers: troposphere, stratosphere, mesosphere, and thermosphere. Shall we talk a little about the thermosphere? Let's go. The fourth layer, thermosphere. It is the fourth layer. Okay. And it is called the thermal layer. Why? Because it is the hottest layer. Also, why? Why the hottest layer? Okay, we've talked about the mesosphere, and we saw the mesosphere was the coldest layer because the temperature keep decreasing till we reach the top of the mesosphere. We notice that the temperature become minus 90 degrees. And as we go up in the thermosphere, we notice that the temperature keep increasing till we reach the top of the thermosphere. We notice that the temperature become 1200 Celsius, and this is a number. So the coldest layer, mesosphere; the hottest layer, thermosphere. Okay, characteristics of thermosphere. It extends from 85 kilometer till 675 kilometer. So the thickness of the thermosphere equals 590 kilometer. So 675 minus 85 equals 590. Okay, the temperature, and I've talked previously about temperature 1200 degree. Okay, and within the thermosphere, in the, specifically in the upper part, we can find the ionosphere. So in the upper part of the thermosphere, we can find the ionosphere. What's important about the ionosphere? Okay, the ionosphere contains charged ions. So once you hear charged ions, ionosphere, charged ions, ionosphere. The ionosphere plays an important role in the wireless communication and broadcasting. Why? As it reflects the radio waves transmitted by radio stations and communication centers. So let's consider here, we have the communication center and radio stations. And here maybe we have the ionosphere. We have waves transmitted from the radio stations and the communication center. And then once it hits the ionosphere or reaches the ionosphere reflects these waves to us. So what is the main important thing about the ionosphere? It reflects the radio waves transmitted by the radio stations or communication centers and reflect it to us. Okay. What else? The ionosphere is surrounded by 2 magnetic belts. These magnetic belts are known as Van Allen belts. So the ionosphere is surrounded by Van Allen bells. And these Van Allen bells are magnetic bells. They are not electronegativity or electronegative or electric or maybe electromagnetic. No, it's only magnetic. So you may ask, you give choose the correct answer. Van Allen bells are magnetic, electric, electromagnetic. It's only magnetic bells. Magnetic bells. Okay. These bells play an important role in what? Okay, we will see. We may say scattering or dispersing, but it's commonly said scattering. Scattering is a harmful charged cosmic radiations away from the Earth. Okay, let me explain this. Here we have, let's say this one is a sun. Okay, these cosmic harmful radiations. Actually, you are not need to know the details, but just keep this clear. And here we have the sun, the earth. I'm sorry. Here we have the sun, and here we have the earth. Okay, we have cosmic harmful radiations come from the sun. These radiations try to get into the earth. What happened? The Van Allen bells, which are the magnetic bells around the ionosphere, scatters the harmful cosmic radiations, forming aurora phenomenon. What's meant by aurora phenomenon? This one that is moving, this one is the aurora phenomenon. Okay. Aurora phenomena appear like a brightly colored light curtains. You know the curtains in our homes? When you see the aurora phenomena at first, you will observe it looks like a curtain. So aurora phenomena are brightly colored light curtains. Where we can see them in any place on Earth? No, especially in north and south poles of the Earth. Okay, when you ask, you give reason. The occurrence of aurora phenomenon. Okay, due to scattering the harmful cosmic radiations by Van Allen bells. Okay, I hope this was clear enough. Okay, and one last thing. Ionosphere extend about 700 kilometers above sea level. 700 kilometers. Okay, the last thing. Exosphere. Exosphere, it is a region in which the atmospheric envelope is inserted with the outer space. The atmospheric envelope is inserted with the outer space. Okay, what is the importance of exosphere? It is a layer in which satellites. So where we can find satellites in exosphere. The satellite orbit around the Earth in the exosphere, and with cameras and telescopes. Okay, what is used for? The importance of satellites. Satellites are used to transmit weather conditions and information and TV programs. So to see the channels on the TV, you need to know that we are having satellites. Satellites are important for what? For transmitting weather condition information and TV programs. Okay, so again, in the exosphere, what we can find? We can find is satellites. Satellite orbit with the Earth. Which one is this one? Is the Earth. Here we have satellites orbit around the Earth. Okay, and as you can see here, look at this video, at this one. It's orbiting around the Earth. Why? To transmit weather condition and information and TV program for us. Okay, I hope this was clear enough. If you have any inquiries, comment below, and thank you for watching. Bye.